All right, I want to talk about some seriously fucked up shit.
Hit me with it.
Let's dive into supermassive black holes. You know, those cosmic monsters that can swallow stars whole?
Literally.
We've got a stack of research here, some pretty wild theories.
Sounds right up my alley.
And you're here to break it all down for us, so buckle up.
Yeah.
Because this is going to get heavy.
I think heavy might be an understatement.
How so?
We're talking about objects millions, sometimes billions, of times the mass of our sun, all crammed into a space smaller than our solar system.
Okay, so let's cut the crap.
Sure.
What the hell is a supermassive black hole anyway?
Simplest terms. It's this region of space-time. Gravity so strong, nothing, not even light, can escape.
Yeah, okay, but how do they even form?
They form from the gravitational collapse of massive stars.
That makes sense.
Or, and this is where it gets really mind-blowing, potentially from giant gas clouds in the early universe.
Hold up. You're telling me a giant gas cloud can just decide, hey, I think I'll be a black hole today.
Well, not exactly decide.
Then what?
It's a fascinating theory called direct collapse.
Okay, I'm listening.
In the early universe, picture these massive gas clouds getting bombarded with Lyman-Werner radiation.
Lyman what now?
Lyman-Werner radiation.
Sounds intense.
It is. Think of it like a cosmic microwave, just blasting these clouds, preventing them from cooling and forming stars.
Gotcha. So they couldn't form stars, then what?
Well, without stars to disrupt them, these clouds could collapse directly into these massive black holes.
So they were just too hot to handle and went supernova on a whole nother level.
You could say that.
Damn. That's some next level shit.
And to add to the weirdness, we've found supermassive black holes so early in the universe's history that they kind of mess with our current models.
Seriously?
Yeah, we're talking about black holes like J0313, 1806. This thing existed when the universe was basically a baby. It's like finding a dinosaur fossil in your backyard.
It just doesn't fit.
Exactly.
That's insane. So the universe was in a hurry to make these monsters, huh?
It really makes you wonder what else we've gotten wrong about the early universe. Some scientists even think these early black holes might point towards a big bounce scenario.
Hold on. A big bounce.
Yeah.
You mean like the universe is just one big cosmic yo-yo?
It's a theory that the universe cycles through periods of expansion and contraction rather than just the traditional Big Bang.
Mind blown.
Okay, but back to these black holes. How the hell do scientists even know they exist?
Good question.
It's not like you can just, point a telescope up and see a big black void.
Right, we can't actually see the black hole itself because light can't escape its pull.
So then how do we know?
We can see how its gravity affects everything around it.
Yeah.
Think of it like this. You're trying to figure out what's inside a locked room. Yeah, okay. But you can only look at the shadows it casts on the wall. That's kind of what we're doing with black holes.
Interesting. So what kind of shadows are we talking about here?
One way is by looking at how light acts near a black hole.
Remember the Doppler effect? Like when a siren sounds higher pitched as it gets closer and then lower as it moves away?
Yeah, vaguely. Something about sound waves.
Exactly. Sound waves and frequency. But light waves can be affected by the Doppler effect, too.
No way.
Yeah, so picture matter orbiting a black hole, crazy fast, close to the speed of light.
Okay, I'm picturing it.
The light from the stuff spinning towards us gets squished. It's called blue shifting. And it looks brighter.
Huh.
On the flip side, the light from the stuff spinning away gets stretched or redshifted and appears dimmer.
So it's all warped and uneven.
Exactly.
Like a messed up cosmic disco ball.
Something like that. And get this, we have the EventHorizon telescope.
What's that?
It's a network of telescopes all around the world that actually captured an image of a black hole shadow back in 2019.
Wait, they took a picture of a black hole?
They did.
No shit.
It was huge for astronomy. First direct visual evidence of these things.
Yeah, science really is fucking cool
And
sometimes.
so, right?
But back to those warped disco balls.
Yeah.
Is that the only way we can spot these hidden monsters?
Not the only way. We can also look at how stars move around a black hole.
How so?
The faster they're moving, the more massive the black hole has to be to hold them in its grip.
Like a cosmic mosh pit.
You got it.
And the black hole's the DJ.
Exactly. And sometimes those mosh pits get even wilder when galaxies collide.
Now we're talking.
Because they bring their own supermassive black holes along for the ride.
Galactic carnage. So what happens when these black hole behemoths meet? They just devour each other. Like a cosmic cannibal buffet.
It's more like a cosmic dance of destruction. When galaxies merge, their central black holes get pulled together by gravity, and they form a binary system.
A binary system.
Yeah, imagine two heavyweight boxers circling each other, but these guys can warp space-time.
Hold on, warp space-time.
Yeah.
Sounds like some interstellar shit.
It is! As these black holes get closer and closer, they release gravitational waves like ripples in the fabric of space-time. We can actually detect these waves here on Earth.
Wait, are you saying we can, like, hear black holes colliding?
Not here in the traditional sense, but we can detect the distortions they cause in space-time using these super sensitive instruments.
Holy shit. That's incredible.
It's like listening to the universe's heartbeat, and it's telling us these cosmic collisions are happening all the time.
My brain is officially fried.
We're just getting started.
Okay, but before we go any further, I gotta know, is there any limit to how big these black holes can get? Can they just eat stars and galaxies forever until the whole universe is one giant black hole?
It's a question that keeps a lot of cosmologists up at night.
For real?
Yeah, but some research suggests there might be a limit to how massive they can get.
So even these cosmic gluttons can't eat everything?
Well, it comes down to the accretion disk, that swirling cloud of gas and dust that's feeding the black hole.
Right.
Beyond a certain size, the disk becomes unstable.
What does that mean?
It might start forming stars instead of feeding the black hole.
So like a cosmic traffic jam.
Pretty much.
All the gas is trying to cram into the black hole at once, and it just backs up and makes stars instead.
That's a pretty good analogy, and it gets even crazier.
Ow.
There's this concept called stupendously large black holes, SLABs for short.
Cella labs. What the fuck are those? Sounds like something out of a bad sci-fi movie.
They're theoretical for now, but they could be hundreds of billions, maybe even trillions of times heavier than our sun. Just imagine the havoc those could wreak.
All right, now my brain is officially melting. We need a bigger boat to navigate the rest of this cosmic shitstorm.
Hang tight, there's a lot more to explore. All right, so we've been talking about these supermassive black holes, right? And how they're the universe's biggest gluttons.
Yeah.
But they aren't just cosmic vacuum cleaners sucking up everything around them. They actually play a crucial role in how galaxies evolve.
You're telling me these things aren't just agents of chaos?
Nope, not at all.
They actually do something useful.
Absolutely. Think of them as the architects of the cosmos.
Okay.
Their insane gravity acts as this cosmic anchor.
An anchor?
Yeah, holding galaxies together, and as they devour matter...
Which is all the time, right?
Pretty much. They release tons of energy.
Okay.
And that can trigger star formation and just shape the entire structure of a galaxy.
So they're like the ultimate cosmic gardeners.
Kinda.
Planting seeds for new stars and galaxies who knew these monsters had a green thumb.
It's more like a cosmic dance between creation and destruction.
Deep.
And you know what? We even have a fancy name for galaxies with actively feeding supermassive black holes.
Hit me with it.
Active galactic nuclei, or AGNs.
AGN's got it. So these are like the rock stars of the galaxy world.
They're pretty flashy.
Shining brighter than a supernova on a bender.
You could say that AGNs are super luminous, blazing across the universe with the energy of billions of suns.
Holy shit.
And in fact, some of the most distant objects we can see are quasars.
Quasars.
Yeah, a type of AGN so bright they outshine entire galaxies.
That's insane.
It is.
Okay, so we've got these quasars super bright, showing off their cosmic bling. What about the ones closer to home?
There's a whole range of AGNs.
Okay.
Each with its own unique characteristics. Some more energetic than others, some are hidden in dust and gas,
Makes sense.
and others are blasting out jets of particles at almost the speed of light.
Damn, that's some serious cosmic fireworks.
Yeah.
It's like the universe is throwing a rave and black holes are the headliners.
I like that analogy.
But speaking of cosmic fireworks,
Mm-hmm.
what about those black hole collisions we were talking about before?
Yeah.
What happens when those gravitational waves hit Earth? Do they, like, cause earthquakes or some shit?
No, not quite. Gravitational waves are actually super weak by the time they get to Earth.
How weak are we talking?
We're talking distortions in space-time smaller than the width of an atom.
Seriously?
Yeah, it's crazy.
So how the hell do we even detect them if they're that small?
It takes some pretty insane tech. We use these massive laser interferometers.
For what now?
Interferometers, they're basically giant L-shaped detectors with mirrors.
Okay, I'm picturing it.
And they can measure these tiny changes in distance caused by passing gravitational waves.
So it's like trying to hear a whisper in a hurricane, but with lasers and mirrors instead of ears.
Exactly. And the data we're getting from these detectors is changing everything we thought we knew about black holes and the universe.
That's wild, man. I'm starting to see why scientists get so hyped up about this stuff. It's like cracking open a cosmic treasure chest
Right.
and finding all these mind-blowing secrets.
He's pretty amazing.
Speaking of secrets, what about those rogue black holes, the ones that get kicked out of their galaxies?
Oh yeah, the cosmic orphans.
What happens to them?
Well, scientists think they just keep on eating as they roam the cosmos.
So they're like cosmic nomads,
Pretty much.
cruising through space with an insatiable appetite for destruction. That's a recipe for some serious intergalactic mayhem.
It would be pretty scary to see a supermassive black hole millions of times heavier than the sun hurtling through space.
Yeah, no thanks.
At thousands of kilometers per second, just gobbling up anything in its path.
That's some nightmare fuel right there.
It is.
I'm starting to think we should have stuck with those cute puppy videos instead of this cosmic abyss. But before we totally lose our minds, I got one last question.
Shoot.
We've talked about how these black holes grow to be unbelievably huge, but can they shrink too?
You mean like go on a diet?
Exactly.
There's a theory Stephen Hawking came up with that says they actually evaporate over time.
They what?
Evaporate, but very, very slowly.
So you're telling me even these cosmic gluttons can't escape time?
Not even them. They have an expiration date, too.
That's kind of comforting, actually.
It's called Hawking radiation, and it comes from quantum effects near the event horizon.
Quantum effects. Now you're really messing with my brain. Can you explain that in normal people terms?
Okay, imagine the event horizon like a boiling pot of water.
Okay, I'm with you.
Sometimes pairs of particles pop in and out of existence near the surface.
What? Particles popping in and out of existence? What is this voodoo magic?
It's quantum mechanics, the world of the very small anyway, if one of these particles falls into the black hole. And the other escapes, it's like the black hole loses a tiny bit of energy.
So it's leaking energy slowly until it's gone.
That's the idea. But the time scale for a supermassive black hole to evaporate is crazy long.
How long?
We're talking trillions upon trillions of years, way longer than the universe has even existed.
So basically it's a moot point.
Pretty much, we can consider supermassive black holes permanent for now.
All right, I'm feeling a little better knowing these things aren't going to disappear and leave the universe in chaos, but there's still so much we don't know about them.
Definitely, we've only scratched the surface.
It's like we're staring into the abyss and the abyss is staring back.
I like that.
But let's step back from the existential dread for a second.
Sure.
Talk big picture. What about the details?
Yeah.
What would it be like to actually fall into a black hole? Would it be a quick death or like some drawn-out cosmic torture?
Well, it depends on the black hole size.
How so?
If you fell into a small one, the gravity difference between your head and your feet would be so strong you'd get stretched out like spaghetti.
Spaghettification. Damn, that's brutal. So I'd be turned into cosmic pasta. Hard pass.
But if you fell into a supermassive black hole, the gravity wouldn't be as steep. You might survive the initial plunge.
Wait, seriously?
You could potentially live long enough to see what's inside.
Sign me up. What's it like in there?
Well, that's the thing. Once you cross the event horizon, there's no coming back. Not even light can escape.
So it's a one-way trip. You go in, but you can never tell anyone what you saw.
Exactly. And what happens inside is still a mystery.
Really?
Some theories say you'd be crushed into the singularity. Others say you might end up in another universe or even travel through time.
Hold up, other universes. Time travel. Now we're talking.
It's all theoretical, but the possibilities are mind-blowing.
Black holes are like cosmic portals.
Maybe they hold the key to unlocking the universe's deepest secrets.
This whole conversation has been wild. We started with these cosmic monsters eating stars, and now we're talking about alternate universes and time travel.
It's a lot to take in.
It's enough to make your head spin.
It is, but it's a good reminder that the universe is this vast, mysterious place.
It really is.
Full of wonders and terrors we're only beginning to understand.
True. Okay, so we've been through the cosmic ringer with these supermassive black holes.
We have.
We've talked about how they form,
Right.
how they mess with space-time,
Yeah.
and how they might even evaporate, but like over a ridiculous amount of time.
Trillions of years.
But there's one thing that's still bugging me.
What's that?
What happens to all the stuff that falls into a black hole? Does it just get squashed out of existence?
That's where things get really weird.
Oh, I'm sure they do.
All that matter gets compressed into this infinitely small point.
A point.
Yeah, it's called the singularity.
A singularity. So like the universe's ultimate trash compactor,
Kind of.
crushing everything down to nothing.
It's more like a point where physics just breaks down.
So we have no idea what happens there.
It's one of the biggest mysteries in astrophysics.
So it's like the cosmic version of here be dragons on a map. Just a big unknown void.
Pretty much we can guess, but we just don't have the tools to understand what's going on. inside a black hole.
That's both terrifying and fascinating. At the same time, it's like staring into the abyss
Right.
and realizing it's staring back at you.
Right.
Okay, but let's step back from the existential dread for a second.
Sure.
We've talked big picture, but what about the smaller details? Like, what would it actually be like to fall into a black hole?
I mean, it depends
On what?
on the size of the black hole. If you fell into a relatively small one, the gravity difference between your head and your feet would be so intense.
What would happen?
You'd basically get stretched out like spaghetti.
Seriously?
Yeah, it's called spaghettification.
Spaghettification. That's a brutal way to go. So you're saying I'd be turned into cosmic pasta? No thanks.
But if you fell into a supermassive black hole,
Okay.
the gravity wouldn't be as steep. You might survive the initial fall.
Wait, really?
You could potentially see what's inside.
That's wild. So what's it like in there?
Here's the catch. Once you cross the event horizon, there's no coming back. Not even light can get out.
So you could see it, but you could never tell anyone about it.
Exactly. And what happens inside is still up for debate. Some theories say you'd be crushed into the singularity,
Makes sense.
while others say you might pop out in another universe or even travel through time.
Hold on. Other universes. Time travel. Are you serious? So black holes are like cosmic portals to other dimensions.
It's all theoretical, of course, but it's definitely intriguing. Black holes really challenge our understanding of physics. They might be the key to some of the universe's biggest secrets.
This whole conversation has been a trip we started with these cosmic monsters swallowing stars, and now we're talking about alternate universes and time travel.
It's been a wild ride.
It really has my head spinning, but I guess that's what happens when you dive deep into the mysteries of the universe.
It's a reminder that there's so much out there that we don't know, and that's pretty exciting.
Totally. It makes you want to keep looking up at the stars and keep asking questions and never stop exploring, right?
Absolutely.
Well, folks, I think we've reached the event horizon of our own deep dive today.
I think so, too.
We've gone from how these supermassive black holes form to how they might die. And we even touched on some crazy theories about what might be beyond the singularity.
We covered a lot.
But I think the biggest takeaway is that the universe is a place of endless possibility.
It is.
So keep looking up at the stars, keep those questions coming, and never stop exploring the unknown. And remember, if you ever find yourself near a black hole, try not to get spaghettified. Catch you next time, folks.